endpoints for read and write, read endpoints for read operations. If you clearly know which endpoint to use for writing, use for primary endpoint, you cannot write to read endpoints. But in my Visual Studio, I have defined my primary endpoint and my read endpoint, and then I'm going to create a class called connection multiplexer and given these two endpoints. You can include any number of Redis endpoints or nodes here, but the proper way to do this one is to only give the primary endpoint and the read endpoint. You only keep a singleton instance of this connection multiplexer. So although it's a disposable object, you are not going to dispose it every now and then, but this is an example, therefore it is keep it. I also create a database by calling Redis get database. That will return a database which I can later use to do some operations. And I use a db string set to set a value called my value with the key my key and set the timeout as 600 seconds. And you can also define how to set this object. So always make sure if there's no object, it will update it. If there's an object, it will update it. Exist will set the value for the object exist. Not exist means that it will only update if there's no such object. The default value is always, you can leave it as it is. And also you can specify the command flag, which specify which node you prefer. Of course, this is write operations because I'm going to set the string. So in this case, I want to have the master as my preferred node. This is not a mandatory one. You can ignore it, and in this set string will automatically identify it. But in this case, I'm specifying master as my node. So when I run it, I set the string, and I can now read the value. Read the value, you can see the value is now my value. If you use the wrong command flag, so let's say this read write operation, I use demand replica, which is for read only operations, it will throw an exception. So here, if I continue to throw an exception, so ideally you don't need to specify the command flag, you can let the connection multiplexer manage it. So in this case, I'm just going to set the key and the value along with how long I want to keep this object. And in this case, I can easily write it, and I read the value with the correct value that I save. Redis provides complex data operation that includes publisher and subscriber model. Where publisher publish to a given channel, and all the subscribers can listen to that and get that message. I created two console applications. One is called my Redis publisher, the other one is called my Redis subscriber. So in the publisher, creation of the connection multiplexer is same as before. I create this interface called my subscriber and then publish a message called hello to a channel called messages. I have a subscriber called my Redis subscriber. Connection multiplexing is same as before. I get a name for subscriber, and I then listen on the channel messages, and whenever a message arrives, I bring it to the console along with the subscriber name. I also have a read line to make sure that the program won't terminate. Let's start two instances of subscriber. For the first one, it's called sub1. Let's start another instance called sub2. And let's start the third one called sub3. These are all subscribers now listening to the channel called messages. And let's now run the publisher, which will write a message called hello. You can see that all the subscribers receive that message. When you run it again, they've got that message almost in real time. Multiplexer is same as before. I get this interface called my subscriber and then publisher.
Hello everyone, and thank you so much for joining us for Amazon MemoryDB for Redis Fundamentals. My name is Zach Gardner. I'm a Senior Solutions Architect with AWS, and I'm really happy to be presenting new content on Amazon MemoryDB, a service that we launched fairly recently, and excited to provide more of a deep dive into different use cases and patterns we've seen that MemoryDB can help customers achieve, as well as ways in which you can make migrations into Amazon MemoryDB for Redis, as well as what differentiates Amazon MemoryDB for Redis from some of our other in-memory services. So again, thanks so much for joining us in this webinar. First, it's important to think about modern real-time applications and the different dimensions about these applications that really stress systems and would be better served choosing a purpose-built database to help meet some of these objectives that you see on the screen here. So users upwards of over 1 million, data volumes of terabytes to petabytes, and being able to retrieve data consistently with high performance and low latency, thinking microsecond to millisecond latency. And this request rate, which can span millions of requests per second across a variety of consumer-facing channels such as mobile, IoT, devices, and so on. But also the ability to do it with cloud economics in mind, such as the ability to scale up or scale down or scale in and scale out. And the ability to pay as you go in terms of the consumption of those resources. So all of this to say that AWS purpose-built databases provide an effective way to align your application requirements with the underlying ways to store data. And we've seen these applications, these purpose-built, modern real-time applications being leveraged in e-commerce and media streaming, social media, online gaming, shared economy, and these really fit the profile of these globally distributed applications. With that context, Amazon Web Services has purpose-built databases in order for you to choose a purpose-built engine with all the managed service benefits to get up and running quickly, securely, and reliably. And this spans multiple different pillars, as you see here, such as relational with Amazon Aurora, for Postgres and MySQL, as well as Amazon Relational Database Service for commercial and open source engines, running those traditional relational workloads which require referential integrity and high consistency as it relates to the transactional processing of data. But also, if you think about your access patterns, there may be an opportunity to choose a more purpose-built specialized database to accommodate more common access patterns, such as key-value access with DynamoDB, a serverless NoSQL database, or document-oriented access with Amazon DocumentDB, and even more specialized databases such as Graph or highly related data. And Amazon Neptune is a purpose-built managed database offering service for that use case. And the list goes on with Amazon Time Streaming and Amazon QLDB and Amazon Keyspaces for Apache Cassandra compatible workloads. Our session today is going to zero in on in-memory databases and in-memory caching services. And you see two offerings under this pillar. First is Amazon Elasticache, which many people understand is a caching engine for Memcached as well as for Redis. And then recently announced is Amazon MemoryDB for Redis, which rather than being used as a cache to help augment some of these other purpose-built databases, instead Amazon MemoryDB provides the durability of a primary database while allowing you to achieve microsecond in-memory reads off of the in-memory layer itself. So Amazon MemoryDB for Redis works extremely well as a primary data store, and Amazon Elasticache for Redis or Memcached works extremely well for caching workloads. So this is a bit of how the in-memory pillar of AWS purpose-built databases has evolved. So we're going to zero in on this layer and talk around more differences between the two services, as well as certain use case and patterns that Amazon MemoryDB can be used to leverage. First, it's important to understand, well, what are some of the characteristics of your workload that you want to consider that would require storing the data in memory? Obviously, this is a very different way of storing information than traditional disk-based databases, which can incur greater storage latency when compared to operating data in memory. So what types of requirements would you expect here to consider storing data in memory? First is, I think, an obvious one, is latency, and the ability to retrieve information consistently consistently, with extremely low latency, thinking microsecond reads or single-digit millisecond writes. And in order to achieve that consistently, it's very important to consider memory DB or in-memory databases as one way to achieve that objective. The next is, and as you think about the workload as it scales, is the ability to keep up with extremely high request rate, thinking thousands to millions of reads and or writes per second. And these reads and writes can definitely strain a database if it's not being used correctly. And Amazon MemoryDB for Redis with the in-memory reads and the single-digit millisecond writes can consistently achieve this type of concurrency by leveraging some horizontal sharding capabilities that we'll dig into a little bit throughout this session. And finally, data volume. And it's important to note that while Amazon MemoryDB for Redis can scale to up to 100 terabytes in-memory data, it does not have to go that high, especially as you get started. We've seen clusters spun up with as few as 13 gigabytes of in-memory storage, durable storage for those workloads that start small and then have the elasticity to scale up or scale out the workload in the future. So in terms of industry use cases or domains where in-memory databases are served quite well, firstly, in retail, customer profiles and accounts. Anytime you want a large pool of customers or entities to be able to retrieve their information consistently with low latency in a key value access pattern, then a customer profile or a key value document object work really well in this situation. And we'll look at some examples in the demonstration coming up in a little bit. Other more specialized lookups such as inventory and tracking and fulfillment, so the ability to make many requests at a time, to do it consistently, as well as to manage lots of highly dynamic data without introducing any additional storage latency, so accessing the data directly from memory. Extension of this happens in gaming, of course, the classic Redis use case, which is a leaderboard modeled in Redis, if you know, as a sorted set, as an in-memory sorted order of key value pairs. Redis has very purpose-built data structures for specific workloads, and of course in-memory access to the information makes those lookups very fast, and with Amazon MemoryDB, the durability aspects ensure that we're helping to defend against data loss of traditional Redis architectures that I'll cover in a little bit here. And moving on from there, it's player data stores. So again, very similar to a key value lookup based off of the primary key, a session history, and being able to model that information, report on that information, perhaps using more specialized Redis data structures as well. And you see additional use cases such as in banking and finance with user transactions, or to be able to make decisions in the moment with real-time latency, such as through running different lookups in order to detect fraud, as an example. And then in media and entertainment, very similar user data stores, real-time streaming and analytics. Redis also has a specific stream data structure, as well as some other more specialized mechanisms to capture, ingest, and process this real-time information. So given we've highlighted some of the benefits of storing data in memory, and we'll touch on in this session some of the durability aspects that Amazon MemoryDB provides in order for you to use it as a primary data store, as opposed to maybe a more traditional use case of Redis and Amazon Elasticache for Redis as a cache. Let's look at some of the fully managed service features, such as the Redis compatibility with Redis 6.2 at this moment, with fully compatible with the open source Redis cluster OSS specification, which provides extreme performance and the ability to scale out your workload across a variety of shards and replicas, and we'll touch on some of the cluster specifics in a moment. And then you get, by storing the data in memory, extreme performance. So as mentioned, microsecond reads coming off of either those primary or replica nodes, and then also single-digit millisecond writes, which ensure that data is persisted across multiple availability zones to help defend against data loss. And in similar managed service, benefits, security, reliability, being able to get up and running really fast. We provide network isolation through integrations with VPC subnet groups and VPC security groups, as well as encryption in transit, encryption at rest, all as part of the managed service, multi-AZ configurations, and automatic failover for high availability. And then we see some of the scalability aspects. Amazon MemoryDB for Redis makes it very easy to scale in and scale out your Redis clusters in order to allow you to focus on matching the requirements of your workload, not necessarily the mechanisms and steps involved with scaling, so making it